NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new. More mysterious, more beautiful than humanity's dreams.
Next, the world's most advanced telescope took another leap forward this afternoon as its mirrors were unfolded 1 million miles from Earth. NASA's James Webb Observatory is the successor to the Hubble Space Telescope.
Far beyond the reach of human sight, the James Webb Space Telescope fixed its gaze on what seemed like an ordinary patch of sky and sent back images and data so astonishing that NASA had no choice but to sound the alarm. What Webb revealed wasn't just another galaxy cluster or the trace of some distant exoplanet. It was something profoundly unexpected, so much so that NASA issued a red alert. This wasn't just routine caution or technical jargon. It was a clear acknowledgement that something deep within the universe had defied all predictions, forcing scientists to question assumptions they had believed for decades. The scale, the structure, and the very nature of what Webb detected carried implications that stretched beyond astronomy, reaching into physics, cosmology, and even humanity's understanding of its place in the cosmos. The James Webb Space Telescope was built to push the boundaries of discovery, designed to explore the very edges of light and peer into epochs of cosmic history never before seen. With its unmatched sensitivity, it captures light stretched across billions of years, revealing the earliest stars and galaxies that first lit up after the Big Bang. But this time, Webb uncovered signals that didn't fit the expected narrative of early cosmic formation. What it found were objects that seemed impossibly massive, structured, and luminous, existing at a time when, according to every scientific model, the universe should have been far too young to host such complexity. What should have been nothing more than faint, primitive gatherings of gas instead displayed signs of fully formed galactic systems, as if cosmic time itself had leaped forward by billions of years, shattering all established models. The implications of this discovery were staggering. For decades, cosmology has relied on a clear timeline. The Big Bang, followed by cooling, the gradual condensation of hydrogen into stars, the slow buildup of galaxies, and eventually, the large-scale structure of the universe we know today. But Webb's deep field observations suggested something entirely different. The universe had somehow reached maturity in its infancy. Galaxies that should not have existed so soon after the dawn of time were right there in the data, their light undeniable, their presence unquestionable. If these findings are confirmed, it would mean that our understanding of dark matter, dark energy, and the very physics behind the universe's early expansion would need to be completely rewritten. NASA's red alert wasn't just a call for astronomers to pay closer attention. It was a declaration that Webb's findings had shaken the very foundation of modern science, casting doubt on the cosmological constant, challenging Einstein's equations of general relativity regarding universal expansion, and even exposing gaps in quantum models of particle interactions during the universe's earliest moments. Webb hadn't just captured galaxies. It had revealed a paradox, a cosmic riddle etched into the fabric of space itself. Adding to the mystery were signals Webb detected at wavelengths that hinted at something even more profound. Chemical signatures far more advanced than expected appeared within the atmospheres of distant exoplanets and even in interstellar gas clouds. Webb's instruments were picking up traces of elements and compounds typically linked to biological processes or highly advanced chemistry, a discovery that only deepened the mystery of what lies out there in the universe. These weren't definitive signs of life, but they strongly hinted that the basic ingredients for life might have been far more widespread and available much earlier in the universe's history than scientists had ever believed. To uncover such chemical complexity so soon after the birth of the cosmos raised profound and unsettling questions about how common life might actually be throughout the universe, and whether civilizations, perhaps unimaginably advanced and vastly older than our own, could have risen and fallen long before Earth itself had even formed. NASA's response reflected just how serious this discovery was. This wasn't the kind of finding that could simply be written up in scientific journals and slowly analyzed over years. The red alert meant immediate global action. Teams of scientists across the world mobilized, observatories and telescopes were coordinated, and specialists from fields as wide-ranging as astrophysics, cosmology, quantum mechanics, and particle physics pored over every piece of data Webb had sent back. There was an urgency because this discovery didn't fit into any existing scientific framework. If Webb's detections were accurate, they would shake the very foundation of physics itself. Could the constants we've always assumed to be fixed, the speed of light, the gravitational constant, even the behavior of quantum fields, actually change over cosmic scales? Could the fundamental laws that define reality shift depending on where or when you observe them in the universe? The idea that natural laws themselves might not be absolute but dynamic carried staggering implications. It painted the universe not as a static, unchanging stage governed by eternal equations but as a living, evolving system, one in which even the rules of existence could transform over time. If galaxies could somehow appear fully formed in what should have been an impossibly early era, then the processes driving their formation might come from a realm of physics we haven't even begun to understand. This realization wasn't just a scientific breakthrough, it carried deep philosophical weight. For decades, humanity has sought a theory of everything, a single elegant framework that unifies the smallest subatomic particles with the vast structure of the cosmos. Yet Webb's observations suggested that the universe may not be a neatly solvable puzzle. Instead, it's an endless mystery, with layers of reality that remain far beyond our current comprehension. This red alert also exposed the fragility of our assumptions about cosmic order. For years, the standard model of cosmology has been an extraordinary success story. Observations of the cosmic microwave background, galaxy distribution surveys, and studies of dark energy's mysterious effects have all reinforced its accuracy. But Webb's data shattered that sense of confidence, showing that even the most trusted models can crumble when confronted with raw evidence from the universe itself. It was a humbling reminder that science is not a monument of certainty but an ongoing dialogue between theory and observation, where even the most celebrated equations can be rewritten in the face of new discoveries. Beyond its philosophical impact, these findings could dramatically reshape our understanding of the mechanics of the early cosmos. If massive, mature galaxies existed far earlier than anyone thought possible, then supermassive black holes, the engines that shape galaxies, may have been seeded almost immediately after the Big Bang. This would mean that black holes grew and evolved at an almost unimaginable pace, influencing not only galaxy formation but perhaps the very structure of space-time itself. Webb's instruments might already be detecting the first hints of this influence in the form of gravitational distortions, ripples in space-time created by ancient cataclysmic events. Those gravitational wave signatures could hold clues about the universe's earliest moments, revealing secrets about the very birth of reality. But there's an even darker and stranger possibility. Some scientists have begun to speculate that what Webb is seeing might not be galaxies at all. Instead, these observations could point to exotic, theoretical structures predicted by advanced physics, primordial black hole clusters, vast cosmic strings stretching across space, or regions where entirely different physical laws reign. If this is true, Webb may have uncovered evidence not just of anomalies within our own universe, but of other dimensions or realms where space and time behave in ways we can barely imagine. The red alert symbolized more than a historic scientific discovery. It was a warning of disruption, a signal to scientists and humanity alike that the cosmos is far more complex, mysterious, and unpredictable than anyone had dared to believe. It forced a reevaluation of everything we thought we knew, our timeline of the cosmos, the very origin of matter, and even our own trajectory as a species within this vast, mysterious universe. If life could have begun so early elsewhere, then humanity's uniqueness was suddenly cast into doubt. And if the very laws of physics themselves were now in question, then the foundation of all technology and knowledge could be standing on shifting ground. The James Webb Space Telescope had already been celebrated as a window into the earliest chapters of time, but with these discoveries, it became something more, a mirror reflecting back the fragility of human understanding. NASA's red alert wasn't an act of fear or hysteria, but a profound gesture of humility. It was an acknowledgement that what Webb had uncovered lay well beyond the boundaries of current comprehension. This alert wasn't just a warning, it was an invitation, a challenge to humanity to look deeper, think bigger, and accept that the quest for truth is not a journey toward neat and final answers, but an unending path through layers of wonder and mystery. In the glow of that red alert, one truth stood out more clearly than ever before. Humanity now stood at the edge of a new cosmic narrative. The universe had spoken, delivering a message through beams of light that traveled across billions of years, and that message was both simple and profound. We do not yet know the full story. What Webb had glimpsed was unimaginable, and yet, it was only the beginning. The images streaming back from the telescope shook the very foundations of what scientists thought they understood about the evolution of the cosmos. Where there should have been nothing more than faint glimmers of newborn stars scattered through darkness, Webb revealed entire sprawling galactic structures, complex and massive systems that should not have been possible. NASA's red alert wasn't the typical language of scientific discovery, it was the acknowledgement of a rupture, a fault line cracking through the very models that guided our understanding of the universe. It was a moment when the cosmos itself reminded us that it is far less predictable and far more complex than even our boldest theories had imagined. The sheer magnitude of this revelation begins with the extraordinary design of Webb itself. Built to succeed and surpass the legendary Hubble Space Telescope, Webb was engineered with unmatched precision, designed to capture the faintest traces of light stretched thin across unimaginable distances of space and time. Its iconic golden hexagonal mirrors were finely tuned to collect infrared wavelengths, allowing it to see through the dense cosmic dust that had long concealed the universe's earliest eras. Where Hubble's view grew dim, Webb's sharpened, providing a portal into the first few 100 million years after the Big Bang. This was supposed to be an era of simplicity, a time when the universe was still a chaotic sea of hydrogen gas, barely beginning to take shape. But Webb's data told an entirely different story. Instead of simplicity, Webb unveiled galaxies blazing brightly in the dark, some so well-structured that they seemed to mock the timeline of creation itself. The shock was not only in their presence but in their sheer scale and mass. These weren't wispy clouds of gas forming their first stars. These were colossal, gravitationally bound systems, filled with billions of stars organized into stunning spirals and massive elliptical forms. Structures like this should have taken billions of years to come together according to the standard cosmological model, yet here they were, fully formed and shining fiercely at a stage so close to the universe's birth that it was like watching a newborn instantly become an adult. This staggering incongruity could not be brushed aside or explained away. The red alert was a message that this wasn't a minor anomaly but a seismic discovery demanding a complete overhaul of the entire cosmological framework. Scientists pored over every detail with an urgency rarely seen in astronomy. Webb's deep field images were examined pixel by pixel, its spectral readings dissected line by line. The redshifts of these galaxies placed them at distances corresponding to times mere hundreds of millions of years after the Big Bang, and Webb's unmatched precision left no room for error. Either these galaxies really did exist at this impossible stage in history, or the entire method by which we measure cosmic distances and interpret expansion was flawed. Both possibilities carried consequences so profound they threatened to rewrite physics itself. If the galaxies were real, then galaxy formation was occurring at a pace so rapid that our current understanding of star formation and gravitational collapse would have to be completely reimagined. If instead the measurements were wrong, then something far deeper was amiss. Our interpretation of cosmic expansion, the value of the Hubble constant, and even the role of dark energy would all be incomplete, if not fundamentally incorrect. And beyond the jaw-dropping structures Webb found, its spectrographs revealed something even stranger, chemical complexity far beyond what scientists had expected at this early stage of the universe. Heavy elements like carbon, oxygen, and nitrogen were already present in surprising abundance within these galaxies. Conventional models of nucleosynthesis, the creation of elements in stars, have long held that such elements required multiple generations of stars and billions of years of gradual enrichment. Yet Webb's findings suggested that the cosmos had somehow fast-tracked its own chemistry, achieving advanced levels of complexity far earlier than anyone thought possible. This revelation raised a startling possibility that planets could have formed in these ancient galaxies, and if planets existed, then the seeds of biology might have been planted while the Milky Way itself was still a fledgling galaxy. Life, in some form, could have been emerging across the universe while our own solar system was still billions of years away from forming. As scientists struggled to make sense of the impossible data, speculation began to push into entirely uncharted territory. One hypothesis suggested that the fundamental constants of nature may not have been as constant as once believed. If gravity's strength, the speed of light, or even the masses of fundamental particles had varied, even slightly, in the early universe, then processes we thought would take billions of years might have unfolded in a cosmic instant. In such a reality, galaxies could have formed almost overnight. Black holes could have grown to unimaginable sizes in the blink of an eye, and stars could have forged heavy elements with shocking efficiency. Webb's discoveries hinted at a cosmos not bound by unchanging rules, but one whose laws themselves might have evolved over time, shifting in ways humanity has yet to measure or understand. The red alert wasn't just a reaction to a scientific breakthrough. It also acknowledged the possibility of profound contradictions between Webb's findings and one of the most trusted pillars of cosmology, the cosmic microwave background. This faint glow of fossil radiation, left over from the Big Bang, has long been treated as a snapshot of the universe mere hundreds of thousands of years after its birth. Its patterns have beautifully aligned with theories of cosmic inflation, dark matter, and dark energy for decades. Yet, if these massive, mature galaxies truly existed so early, then perhaps the microwave background has been hiding subtle signals that we've overlooked, tiny fluctuations that might contain evidence of new physics. It could mean the universe is far more dynamic and unpredictable than the smooth, elegant patterns we once believed told its story. Some theorists began exploring bold explanations. Could these signals be the fingerprints of primordial black holes, ancient seeds left behind by events in the first moments of the Big Bang? If they existed, such black holes could have rapidly devoured matter, accelerating galaxy formation and shaping the cosmos in ways that challenge every model we know. Another intriguing idea was the possibility of cosmic strings, immense filaments of energy stretching across space-time, relics of symmetry-breaking events that may have taken place in the early universe. These exotic structures could have acted as gravitational scaffolds, drawing matter together and enabling galaxies to assemble at lightning speed. If Webb had uncovered signs of such phenomena, it wasn't just revealing galaxies. It was pulling back the curtain on the very architecture of reality, exposing the deep skeleton of space-time itself. The consequences of these revelations didn't stop at astrophysics. If life could have emerged in those first galaxies, then the universe may be teeming with civilizations far older than our own. The idea of intelligent life takes on an entirely new meaning when set against a timeline in which sentient beings might have evolved billions of years before Earth even formed. Civilizations could have risen, reached unimaginable heights, and faded into extinction in epochs so remote that only their faint signals are just now reaching us. Webb's instruments, capable of detecting atmospheric signatures of distant exoplanets, raised the possibility of spotting biosignatures, evidence of life, across the galaxy. Discovering signs of life in star systems older than Earth itself wouldn't just rewrite science, it would forever change humanity's understanding of its own place in the cosmos. NASA's red alert carried more than scientific urgency. It symbolized humanity's first steps into truly uncharted territory, a place where the boundaries of knowledge could no longer be trusted. This wasn't just an adjustment to existing theory, it was a direct confrontation with mystery itself. Webb hadn't merely expanded our vision of the universe, it had destabilized it. The data revealed a cosmos older, stranger, and faster than our most ambitious models had ever prepared us for. The alert wasn't only a signal for scientists to focus their attention, it was a wake-up call to civilization itself, urging us to prepare for a paradigm shift. The findings forced a complete rethinking of cosmic chronology. Instead of a slow and orderly buildup of complexity, the early universe now appeared to have been a furious crucible, forging galaxies, stars, and even planets at a breakneck pace. This new picture suggested that the potential timeline for life might be far broader than we'd imagined. If the cosmos was already bustling with complexity so early, then life could be far more common, emerging in countless star systems scattered across billions of light years. Humanity's sense of uniqueness shrinks in the face of this revelation, replaced by the awe-inspiring idea of a universe bursting with beginnings, a vast tapestry of life stories woven across time and space. The implications didn't stop with philosophy or biology, they extended into the realm of technology and exploration. If the laws of physics themselves shifted or varied across cosmic time and space, then studying those changes could unlock technological possibilities we can hardly imagine. Understanding how gravity or particle interactions behave under extreme conditions might open the door to breakthroughs beyond today's engineering limits. Concepts once relegated to science fiction, faster-than-light travel, extracting energy from exotic matter, or even manipulating space-time itself, could eventually find footing in the new physics hinted at by Webb's discoveries. NASA's alert wasn't just about astronomy, it was about the recognition that the universe itself may contain pathways to a technological future unlike anything humanity has ever envisioned. Yet in all this, Webb's discoveries also humbled humanity. For all our achievements, all our equations and simulations, the cosmos had reminded us that it does not conform to our expectations. It does not bend to the certainty of human logic. The galaxies Webb revealed are there, shining silently, whether or not our theories make room for them. They are a testament to a reality that exists beyond the reach of thought alone, a reminder that discovery is less about domination and more about surrender to vastness, to unpredictability, and to the enduring mystery of existence itself. In the quiet halls of observatories, scientists found themselves returning over and over again to Webb's images. They traced the spirals of galaxies that shouldn't even exist yet, measured the brightness of stars that shouldn't have been born, and analyzed chemical signatures of elements that should have taken billions of years to form. Every calculation pointed to the same startling truth. The universe wasn't following the rules they thought it would. Each piece of data was a revelation, but also a challenge, a message that the cosmos wasn't a puzzle to be solved, but a story unfolding in real time, always staying a step ahead of human understanding. When NASA issued a red alert, it marked a turning point. For centuries, science had built itself brick by brick, refining the models first laid down by Newton, Einstein, and countless others. But Webb hadn't just refined our understanding. It had shattered it. Across incomprehensible distances, in the silence of space, light that had traveled for billions of years carried a single, world-shaking message. The story is not what you thought. And as the world turned its gaze to the stars, it became clear that this wasn't the end of exploration, but the beginning of a new era. A time when the unimaginable was no longer distant, but right here, staring humanity in the face. Webb had unveiled the raw, untamed truth of the cosmos, a universe alive with secrets, daring us to explore. The red alert wasn't a warning of danger but a call to wonder, an invitation to step beyond the boundaries of human knowledge and into the vast unknown. The James Webb Space Telescope wasn't built to confirm what we thought we knew. It was built to uncover what had always been hidden. And in the wake of NASA's red alert, reality settled in. Webb had found evidence so profound that it didn't just stretch imagination. It ripped apart the very seams of modern cosmology. What it had seen in the depths of deep space wasn't just unexpected. It was unimaginable. Signals, structures, and strange anomalies painted a picture of a universe far stranger than anything Earth's brightest minds had prepared for. This wasn't a simple update to humanity's knowledge. It was an invitation to abandon everything familiar and step into uncharted intellectual territory. One of the most immediate shocks came from light itself. The galaxies and celestial objects Webb observed shone far brighter than they had any right to. According to long-standing theories, galaxies from that early era of the universe should have been dim, their stars barely flickering into existence from massive clouds of hydrogen and helium. But Webb's images revealed something else entirely: brilliant, blazing galaxies burning like cosmic beacons, their luminosity rivaling some of the most developed galaxies near us today. This revelation forced scientists to face a chilling possibility. Either star formation is far more efficient than anyone imagined, or these objects were powered by forces and mechanisms that defied everything we know about astrophysics. Speculation began to swirl. Some scientists proposed that these radiant galaxies might not be fueled by ordinary stellar processes alone, but by exotic forms of matter or energy humanity has yet to discover. If this theory were true, Webb's findings would sit at the very intersection of astronomy and fundamental physics. The telescope could be capturing signs of phenomena that hint at other dimensions, undiscovered energy fields, or even interactions between matter and space-time that break Einstein's equations. These ideas sounded radical, but the data demanded answers as bold as the discoveries themselves. Even more startling was the unexpected order in the chaos of the early cosmos. The universe, in its infancy, was long thought to be a turbulent place, a swirling storm of matter still pulling itself into structure. Yet Webb revealed galaxies that already showed distinct spiral arms and elegant elliptical shapes. To see such symmetry so soon after the Big Bang was like finding a perfectly detailed painting on a canvas that hadn't even dried yet. This level of organization suggested that the universe could form structure and harmony far faster than ever believed, perhaps guided by forces still unknown. The cosmos itself seemed to lean toward order, a realization that has profound implications for physics and even for philosophy. But Webb's discoveries didn't stop there. Its powerful infrared instruments turned their attention to distant exoplanets, scanning their atmospheres with unprecedented precision. What they found shocked scientists once again. Molecules like methane, carbon dioxide, and even traces of water vapor appeared in planetary systems orbiting stars thousands of light-years away. And they were there far earlier than models had ever predicted. This suggested that planets capable of sustaining complex chemistry, and maybe even life, were forming much earlier in cosmic history than anyone had imagined. If these planetary systems existed back when the Milky Way itself was just forming, then the odds of ancient life elsewhere in the universe skyrocketed. Life may not be a rare, late development in the cosmic timeline, but something deeply woven into the universe from its earliest chapters. The implications of this possibility are staggering. If intelligence could arise in those early galaxies, civilizations billions of years older than humanity might have come and gone long before humans even existed. Their signals, their artifacts, their technologies could still be drifting through space, faint echoes of worlds that lived and died long before Earth's first sunrise. Webb's discoveries transformed the search for extraterrestrial life from speculation into an inevitable question. If life-supporting conditions appeared early and often, then the question isn't whether we are alone. It's how many came before us, and if any are still out there. As scientists scrambled to understand the meaning of early galactic formation and the chemical makeup of alien worlds, yet another groundbreaking frontier emerged: gravitational signatures. Webb's sensitivity allowed it to detect subtle distortions in light caused by massive, unseen structures. Some of these distortions revealed concentrations of matter so extreme that only black holes of extraordinary size could explain them. What startled scientists was that these black holes seemed to exist far earlier in the universe's history than current theories allowed. Normally, for a black hole to grow into something millions or even billions of times the mass of our Sun, it would require vast amounts of time and matter steadily feeding it. Yet Webb was capturing evidence of such giants in the universe's infancy, defying logic and established models. This forced scientists to consider that either black holes grew at a rate far beyond what was thought possible, or they weren't formed from collapsing stars at all. Instead, they may have originated from direct collapse phenomena in the earliest moments after the Big Bang. If that is true, then black holes could be even more fundamental than galaxies themselves, potentially predating them and shaping cosmic structure from the start. This discovery hints at an even deeper implication: that the very fabric of space-time may have been influenced by these titanic gravitational wells from the very beginning. If black holes formed alongside the Big Bang, their gravitational pull may have guided the evolution of the universe from the very first fractions of a second, altering the path of cosmic history in ways we are only beginning to understand. It raises the staggering possibility that black holes are not merely the end products of massive stars collapsing, but essential building blocks of the universe itself, seeds around which matter has organized, shaping the cosmic web of galaxies and bending light into the grand structures we see today. This revelation wasn't just a scientific breakthrough. It was a message for all of humanity, a wake-up call that we stand on the edge of a profound intellectual transformation. The universe had revealed a narrative beyond what textbooks and equations have long told us, and the challenge now wasn't to dismiss these discoveries as unimaginable, but to confront and embrace them. Philosophers now had to question the assumed linearity and simplicity of cosmic order, while theologians were prompted to reflect on creation, existence, and the origins of life itself. Even technologists were stirred by these findings, as the anomalies hinted at principles of nature that could one day lead to unimaginable technological advancements. Webb didn't just peer into the distant past, it projected humanity's imagination far into the future. One fascinating area of speculation that emerged from these findings was the possibility of variable constants. If the physical laws of the early universe were even slightly different from what they are today, then the processes of star formation, chemical development, and gravitational assembly might have occurred at speeds far beyond anything we see now. This would mean that constants we've always assumed to be fixed, like the gravitational constant or the fine structure constant, might actually shift over cosmic time or vary across different parts of the universe. Such a concept would revolutionize physics, revealing a cosmos that is not bound by rigid, eternal laws, but alive, dynamic, and evolving. In this view, the universe isn't a perfectly engineered machine but a living, breathing process of constant transformation. These discoveries also reignited debates about the multiverse. If Webb has uncovered phenomena that cannot be reconciled with the physics of our own universe, perhaps these galaxies and structures are the fingerprints of other universes bleeding into ours. Theories of cosmic inflation already suggest that countless universes may exist beyond our observable horizon, each with its own physical laws. If Webb's data points to phenomena that can't happen under our known constants, then we may be glimpsing subtle interactions with these parallel realities. What we're observing might not be the story of just our universe, but part of an overlapping, multi-layered narrative where universes coexist and influence one another in mysterious ways. For humanity, these implications stretch deep into questions of identity and meaning. We've always imagined ourselves as latecomers to a universe that slowly evolved toward complexity. But Webb's revelations suggest something far more profound, that complexity was present from the beginning, that the cosmos was primed for richness, structure, and even life from its earliest moments. In this view, existence itself isn't a rare accident but an inevitable expression of the universe's fertile nature. The red alert issued by NASA symbolized a major shift in perspective, a declaration that cosmic modesty is dead. We are not fragile products of a lucky alignment of conditions. We are the natural result of a universe that has been bursting with possibility since its birth. This marks the start of a new chapter in science. Researchers are now reworking theories, crafting new models, and launching further investigations, while humanity faces a cultural challenge to integrate this expanded vision of reality into our understanding of who we are. Just as Copernicus removed Earth from the center of the cosmos and Hubble revealed a universe of countless galaxies, Webb has once again rewritten the story, placing humanity in a universe that is older, faster, and stranger than we ever imagined. The red alert was never a warning of fear, but a call to awakening, a reminder of the universe's ability to astonish us again and again. Now, the boundaries of knowledge themselves feel transformed. Where we once sought ultimate equations and final theories, we are beginning to realize that the universe may never fit into a neat, complete framework. Webb has shown that every answer leads to deeper questions, that the unimaginable is not a boundary but an invitation to see further. The galaxies that should not exist, the black holes that should not be there, the atmospheres that should not have formed so early, these are not contradictions but clues, urging us to expand our vision and embrace the mystery of existence. As light from those ancient galaxies continues to pour into Webb's mirrors, one truth becomes undeniable. The cosmos is not only larger than we imagine, but larger than we are capable of imagining. NASA's red alert was more than a technical message. It was a communication across time, a profound recognition that we are still at the very beginning of understanding the universe. And in that recognition lies the true beauty of discovery, not in finality, but in the endless unfolding of mystery. If you enjoyed this video, don't forget to give it a like and subscribe to our channel. Share your thoughts in the comments below. What do you think of NASA's red alert after Webb's discoveries? We'd love to hear your perspective. Thanks for watching, and we'll see you in the next episode.